It's the Eurythmics on BBC Radio Sheffield. I'm Kat, sitting in for Howie, and we've got Sports Bleep on the go. So I have got a little clip of Roger Federer talking about a time in his season last year when things weren't going as well for him as he would hoped. And I've bleeped out a word, and all you have to do is tell me what word I bleeped out. Now, Bertie Blade got in touch to say that he thinks that the word I've bleeped out is epic, but if you just, it's when things weren't going as well for him. So have a listen.
Last year we had a quarter-final. I was down 2-0 and match points down, I think, in the third or in the fourth set.
So when things weren't going great for Roger Federer, I've bleeped out a word. What word have I bleeped out?
Last year we had a quarter-final. I was down 2-0 and match points down, I think, in the third or in the fourth set.
Let me know, 279 if you're calling, or you can text me 81333. Start your text with the word Sheffield and I shall reveal all shortly. It is 41 minutes past 5, and a new discovery by scientists at the University of Sheffield could help slow down the progression of diseases like motor neuron disease and dementia. By tinkering with a specific gene that helps repair DNA, this could prevent the nerve cells dying. It's the death of these nerve cells which trigger diseases like dementia. Professor El-Khamisy is behind the study, and it sounds like a very complex study, but could you do your best, Professor, to explain it in layman's terms?
Yes, of course, my pleasure. So our DNA, where all the information and instructions is stored, is not stable. It's prone to attacks all the time. So we have about 7 DNA breaks in our genome per cell per minute. So this is a very high number. And the cells are equipped very well with machinery and toolkits to fix these high number of breaks as and when they arise. However, if they don't do that properly, a neurological disease can arise, and many other diseases can arise. In this particular study, what we found is a repetition in a gene called C9. This gene is the most common cause of motor neuron disease and also some forms of dementia. It has also been linked to other forms of neurological disorders such as Parkinson's and Alzheimer's. So what we found is when this repetition exceeds certain limit, the DNA, when it tried to translate and transcribe its information to make useful proteins, the actual double helix melt and exposes one strand of the DNA to this huge number of attacks that happens all the time. So you end up with a lot of DNA breaks, and lots of DNA breaks is not good for the nerve cells, and eventually they die.
Okay, so what can you then do with this information? How could it help people with motor neurons and dementia?
So what we're trying to do now is to try to boost up the ability of the cells to repair their DNA using viral vectors and gene therapy. And we've done some experiments in vitro in the lab that shows us that this actually approach can work, and by boosting up the DNA repair capacity of the cell, you can prevent this high number of DNA breaks and you can rescue neurons from dying.
How excited can people who are listening at home who are perhaps affected by motor neurons disease, or indeed, like many of us, are worried about dementia, how excited can we be about something like this?
It is still in the very early phase. It's all studies done in cell culture and also in mouse models. So what we're trying to do now is to engineer these vectors in viral vectors and try to test them in the appropriate mouse models. And if that works, then we will go to the preclinical studies and try to test them in patients. So I would say it's a very good step forward. It paves the way to new approaches for treatments, but we're still not there yet.
And this would be, it sounds like it would be a treatment rather than a preventative measure.
Absolutely right. Yes.
And that moment when you discovered this, you saw it as a scientist. How was that?
It was amazing. It was really exciting for the whole team, and this is like a combined effort from different departments at the University of Sheffield. And it's the first author on that paper is a PhD student, and he's just about to finish. So it's very inspiring and very rewarding for him to find that sort of discovery. And I'm sure he will be witnessing and waiting to see it transforming, hopefully, to treatments for these patients.
Well, I think everyone hopes so. Professor Sharif El-Khamisy, thank you so much, and good luck with your further research.
Thank you.
Hello, Greg. How's it looking?
Hi, Kat. Today's on the A1M now, southbound in the Doncaster area, just at junction 37 at Mar. A lorry's broken down, blocking off lane 1, looking very slow. Thanks for your calls on that. Apart from that, traffic's fine on the M1 and the M18. In Chesterfield, it is looking heavy, though, on Rotherway on the A61 in both